This is geometry, lesson on linear measure. First off, a line segment. A line segment is different from a line because it has two endpoints. Since it has two endpoints, it can be measured. Here would be a diagram of a line segment. There we have two endpoints. Here our endpoints can be called A and B. That would be a line segment. Our notation for line segment is we write down the two letters of our endpoints. So we write down our letters A and B, and we would draw a little line above it. This indicates that we are talking about line segment AB. Now, if instead of talking about the line segment AB, if we wanted to talk about the measure of AB, there's also a way to indicate that. The measure of AB is written as just AB with no symbol above it and no other indication. Okay, so if we want to find the measurement of that, our symbol is just the two letters written next to each other. We will also be talking about betweenness of points. Betweenness of points refers to the fact that we can always have points that lie in between two of them. So let's say we have this line, and on this line we have the points A, B, and C, and then somewhere off of the line we have the point R. On this line, we can say that point B is between points A and C. However, point R is not between anything because it is not on the line. Furthermore, when we have the betweenness of points, the whole measure will be equal to the sum of the parts. So what that means here is we have a whole measure. If we wanted to find the whole measure from A to C, that whole measure from A to C would equal the sum of the parts. So one of the parts is from A to B, and the other part is from B to C. So that's our betweenness of parts. The whole measure is equal to the sum of the parts. Notice here we are just writing the letters, which indicates that we are discussing the measurements of those. And the final new word we need to learn about is congruent segments. Congruent segments, we have two segments with the same measure. That can be indicated either by having a diagram, and in the diagram, the two measurements are both labeled with the same measurement. So here, RST can be our diagram. If these both are labeled as 3 inches, we certainly know that they are congruent. However, we won't always have measurements, so instead, a similar diagram, I'll label it X, Y, Z. We can also know that the two lengths are congruent if we have these tick marks. If they both have one tick mark, that means that they are congruent. Or if they both have 2 tick marks, that means that they are congruent. If I were to add on to this diagram here, add a W down there, and put 2 congruent marks there, this tells us that WX is equal to WZ because they have the 2 congruent tick marks, and XY is equal to XZ, or YZ. Now notice we're using the equal to sign because we're referring to measurement. If we want to refer to congruence, we have to talk about the line segments themselves. So here we would say WX, the line segment, is congruent to WZ. And this is our congruent to symbol. It has an equal mark with that squiggle or the tilde mark on the top. Furthermore, we could also up here say that XY, the line segment XY, is congruent to the line segment YZ. And once again, because we are using line segments here, we have to make sure that we use the congruent mark because we're talking about the line segment. All right, so now we're going to find the length. This is just basic using your ruler skills. This is something you should know how to do. Here I've got a ruler and we have a line segment. So first off, we have to make sure that our line segment and the ruler are lined up in the same location on 0, and they are. So we go to the ending point, we look straight down and see where it is. That looks like it is at 6.5, and this ruler is in inches, so we would say 6.5 inches. Okay, our one further down. First check to make sure that they're lined up, and it appears as if they are. So we go over to where it ends. Here it ends. You look straight down there and figure out where we are. So here's 2, and then we're not exactly in the middle this time. Instead, we are 1, 2, 3, 4, 5, 6 eighths of the way over, which is the same as 3/4. So we'd say this is 2 3/4 inches. Always make sure you label. If you do not know the label, you're going to use the word units. All right. So now let's talk about finding measurements and betweenness of points. So here we have 3 diagrams, and we want to find the indicated measure. So for this first diagram, we want to find out what WX is. We want to find the measure of that line segment, WX. So here we see that point X is in between W and Y. We also see that the entire diagram here is labeled as being 6 centimeters. And we notice we have 2 congruent marks. Because we have the 2 congruent marks, we know that the line segment is split up evenly. Since it's split up evenly, we would just have to go, okay, well, 6 divided by 2 is 3. So the measurement from W to X is equal to 3 centimeters. Notice here we are talking about a measurement, so we do not have the line segment notation on top of it. RT, we want to find the length from R all the way to T. So notice here, RT is created of 2 smaller pieces, RS and ST. S is in between R and T. So to do that, we'd have to add these 2 segments together. So we have 2.1 plus 2.4, which would be 4.5. So the measurement of RT is equal to 4.5 meters. Once again, we're talking about a measurement, so there's no line segment notation there. And our third example here is BC. Here I want to find from B to C, so that's only one part of this diagram. Notice that B is in between A and C. We know A to C is 7 inches, and we know A to B is 2 1/4 inches. We know the total distance is 7, and we know one piece of it is 2 1/4, so we would have to subtract these. So we would take 7 minus 2 1/4. Well, 7 minus 2 1/4 is 4 3/4. So the distance from B to C is 4 3/4 inches. Once again, we're talking about a measurement, so we do not have the line segment notation on top of BC. We just write down BC. Now, we won't always be given a diagram like we had been for those examples. So the next one does not have a diagram. We want to just find the value of the variable and RS if S is between R and T. Well, right here, this tells us how to draw our diagram out. It says S is in between R and T. So here's R, here's T, S is in between there. Okay, so there I have my diagram drawn correctly. Now let's label what we're given. Here we're told the measurement of RS is 2x, so we'll label RS as 2x. The measurement of ST is 5x plus 4. So S to T we will label as 5x plus 4. And RT is 32. So all the way from R all the way over to T is 32. Now when we have this, we know that the total length, RT, is equal to the sum of the 2 parts. So we can just create an equation here. So if we take RS, which is 2x, add it on to ST, which is 5x plus 4, that should equal 32. Now we just have to use our algebra skills to solve. So 2x plus 5x is 7x, plus 4 is equal to 32. Subtract the 4 over. 7x is equal to 28. Divide by 7, so x is equal to 4. That was one part of it. We want to find the variable. There's our variable x. Second part is we want to find RS. Well, here we have RS is equal to 2x, and we just found out that x is equal to 4. So RS is 2x, x is 4, so 2 times 4 is 8. So the measurement of RS is 8. So we have two answers here. Our variable x is 4 and RS is 8. We'll do another couple of examples with congruency here. So we want to determine whether the pair of each segments are congruent. So if we take a look at this first diagram, we want to see if the segment XY and the segment YZ are congruent to each other. So we have to look at their measurements. Here's x to y. It's labeled as 3x minus 1. Here's y to z. It's labeled as 3x minus 1. These both have the same exact measurement. So yes, they are congruent. And so we would say xy with our line segment notation is congruent to yz as a line segment. Okay, next example, we have a parallelogram here. We want to know if AB and CD are congruent to one another. So here's A to B. Notice that we have one tick mark on there. Here's C to D. Notice we have one tick mark on there. Those are congruent marks, which tells us that the two sides are congruent, so therefore they are. So here we would say AB is congruent to CD. They are shown as being congruent. The last thing that we're going to do is construct a segment that's congruent to a given segment. So here's our given segment AB. So the first thing you have to do is just draw out another line using a ruler. So you guys are going to have to take a ruler out. So here we are taking a ruler out, and you just need to draw some sort of line segment that is nice and straight using that straight edge of the ruler. Now on here I have the ability to just create a straight edge like so. So there we have our line segment drawn out, and you use the straight edge of a ruler. Okay. Now you need to take your compass. So here we go. Here's our compass. You need to line it up with the edge of one of your points. And then you want to take it and make it so that it is open to the length of your line segment. So I'm going to take this compass and see how I have it open to the length of the line segment. Now you're going to move that compass over to your line that you created, leaving it the same exact length. Put the end right on the end of your line, and then you will take the compass and swing it. Okay, so now we swung that compass around, and we now have a congruent line segment. So we can put a point right there where it intersected the line, and a point at the edge where our compass is. And then we can get rid of our compass here. So this segment, let's label it with two other letters, C and D. We now have shown that line segment AB is congruent to line segment CD. They would be congruent to each other because we use the compass. You certainly can always take out your ruler and double check that length there. So here from A to B appears to be about 5 1/4. If we go over and measure from C to D, that is also at 5 1/4. So we know that we did it correctly.